Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us today to stay curious with these two repeating guests that we love to have. Tracy Gill beside me here. Hi,
Hey,
Tracy.
Mark. How are you doing?
Welcome to our museum again and stay curious. And Mikey Haddad.
Oh,
Mikey,
good to be here, Mark.
always
Yes,
great to
sir.
have you here. Mikey wrote this book. I'm going to show you another picture of it here in a minute. Payloads, Shuttle Space Lab Payloads, and you can get it on Amazon. Show you about that in a minute. And that's the crux of our talks here, is they take you to the people of the shuttle payloads, and you two were two of the level 4 engineers in the Space Shuttle Processing Center, right?
Yes, sir.
SSPF, all these acronyms I've got to learn from Mikey and Tracy. And both have been on here before. Tracy, you've been on twice, like last August was the last time we had you on here. And that was a great program. So you're going to learn a lot about some of the challenges and some of the triumphs of putting payloads on a specific mission today. And that is the International Microgravity Laboratory, where 7 astronauts roared off the pad on July 8th. And Tracy, you got coming right out of your head there. So, guys, good to have you here. Hope your summer's been nice, and appreciate your support and stay curious this way. Tracy, just a brief thumbnail. Where'd you grow up, and how'd you get involved in this space game?
I'm a Florida native. Grew up here. Early memory of getting to see one of the Apollo landings, and I grew up seeing space shuttle launches and just wanted to be a part of it. I have a copy of a paper in high school that I wrote, said I wanted to work for NASA, and was fortunate enough to be able to do it.
Wow. Well, 53 years ago, right now, Apollo 15 was about to do their second EVA with the first lunar rover. We talked about that yesterday. I talked about it for a lot, didn't I, Marty? I went over an hour there saying hi to Marty Winkel, my co-producer over there. We're adjusting our volume, folks, so let Marty know there that the volume's coming in a little better. We're going to keep a better eye on that and maybe get some new microphone situation here, or resurrect our old ones we used to have there. And we've got Logan Cope is our intern from Eastern Florida State College here, and he's been doing a good job. And Marty's going to go on vacation up to New England or Long Island next week, 2 weeks. So, Marty, you want to see some of those pictures of some of the space stops you make along the way. So, and Mikey, always glad to have you here. You're usually here once a month and bringing great guests like Tracy with you. Tell us a little bit about where you grew up and how you got involved in
Well,
space.
actually grew up in Cleveland, Ohio. I was born in Cleveland, Ohio, and grew up there till I was 9. Was there till I was 9. But while I was there, even though we were in Ohio, I got a kind of an itch for the space program. And then we moved down to a little city called Titusville, which I didn't know where Titusville was. So I got on the map, and there it was right across the river from Kennedy Space Center, and I had fallen in love, and that was it. After that, basically, I lived in Titusville all the way through. I went to college over at UCF, got an engineering, mechanical, and aerospace engineering degree, and went right to work at NASA Kennedy Space Center, and then stayed there to basically December of 2011. Retired in
Okay.
2011.
Yeah.
So it was an awesome career. Yeah, I loved every minute of it. But
University of Central Florida really has come a long way since you were eating in their cafeteria, I'm sure.
yeah, it was a really small college. Actually, when I started, it was Florida Technological University. Was the reason I went there, because it was a technical university at the time. And halfway through, they renamed it University of Central Florida to make it more general. And then, of course, from there, it just exploded into the university it is today. Yeah.
Well, we're glad to have both of you here. I've got my smart tablet that I'm activating here to get your comments, and if it's alive, did it go dead on me here? It probably did go dead, but I'm not going to have too many
Plug it in.
comments from you all because Tracy's going to do a lot of the talking. And we're going to first feature the Space Lab Payloads book there by Mikey. I plugged it on our Facebook teaser there that you can order from Amazon. And we got a few autographed copies here at the American Space Museum. Mikey also big part of our Shuttle Fest, has done a great job the last 2 Shuttle Fests getting us guests, and you got surprise Bob Cabana showed up.
Yeah, it was
And,
really,
and
yeah.
he's the commander of this mission
Mhm.
here. There's where we were on in August, guys. And Tracy, you brought some thingamajig from the space flown artifact there that was fun to get. So we have a whole archive of programs on YouTube, and Marty and I have recorded over 1,100 episodes now of Stay Curious in the 4 years born out of the pandemic. And glad that you are all along. It's very important to our museum, the outreach. Mikey wanted to ask you to tell us a little bit about the Astro Restoration Project. How's it coming along? You're
Coming
trying to restore the telescopes that were on 2 space flights. Our late friend Sam Durant's involved with this. So how's that coming along?
It's coming along. Yeah, we're still actively working that. It's being integrated, assembling the telescope package, which you kind of see there, the big red circles and the 2 black circles and the little 3 circles. That's kind of the main components of what we're restoring out there. Cruciform, which is the basic support structure. The 3 instruments are the ones that kind of with the 2 black circles and the red circles. Those are the main instruments. And then the optical sensor package, which has the 3 little kind of cones there. We're restoring that up at the Huntsville University, U.S. Space and Rocket Center in Huntsville, Alabama.
Okay.
It's still taking place. And basically what it is after the spaceflight program was kind of winding down, we went ahead and we actually purchased via the Ransom Road, which is kind of like the junk dealers, hardware that was actually going to be destroyed, and other components too. And a bunch of us saved it over the years, and then we finally got a deal with the Smithsonian and the U.S. Space and Rocket Center in Huntsville to physically put this stuff together to put on display for people to see. And so it's an active display right now. We've got the Wisconsin Ultraviolet Photopolarimeter experiment, kind of the one on the bottom left there, the kind of rectangular one. That one and the OSP, the 3 cone ones to the right, that's actually installed on the cruciform right now up there in Huntsville. You can go see it. And again, it's right there in the atrium. And so we're still working that. We're trying to get the other 2 instruments to Huntsville, continue the integration effort. And eventually, the idea is to have this on display at the Smithsonian up in Washington, D.C. So it's still actively going. We got the Aspiration Project there. It's a page that we had set up. It's a 3051c company. So yeah, anybody that would love to see that or contribute to the project, just contact us. There's contact information on us. It's good. It's going. It's still proceeding ahead. We got a lot of work to do yet. It's going to be a number of years before this is done. So it's a long-term project, but it's a labor of love, and it's something we've wanted to do for a long time, and it's making it happen. So if you ever get a chance to go up to Huntsville to their visitor center up there, it's in the atrium on display. You walk right up to it.
Okay.
And see the hardware on display.
I know a man named Stewart, his last name. Did you deal with him? He's there, and his wife was involved with the Space Coast Office of Tourism a while.
Okay.
And forget, I think it's Dave. It could be Dave Stewart, but so we'll be able to see at the Rocket Center there, just west of Chattanooga, Tennessee. I missed going to both those spots when I was living in Tennessee there. Well, we're going to talk a lot about STS-65. Launched one of the shuttles of the month of month of July. Oh, I put that at the very bottom. Okay, let me go backwards like that. I forgot to move that around. These are the shuttles of the month of July, guys. 11 beautiful shuttles flown that had 65 astronauts, 55 of them women. Don Thomas actually flew twice. STS-65 we're going to talk about at the top, launched July 8th. Then he was on STS-70, the Woodpecker mission, they call it there, on there. And of course, the last shuttle of the month, of the era, the 30-year era, was launched July in 2011, July 8th. Coincidentally, we've got both of, in July, Eileen Collins' commands. STS-93 was the Gamma Ray Observatory, and then the return to flight, 114. And as you guys know, after 114, the shuttle was grounded for a year, and 121 at the top was actually the second return to flight out of sequence. And then they got back to 115 on there. So, yeah, I got you guys live on here so I can pull up some questions from y'all out there. We've got Dave Stangy is watching and looking forward to the show. He said it sounds good. We got Steve Jokums up in Lake County Spaceport. Says hello to everybody here. And Doug Forrest, we featured his artwork from Apollo 15 yesterday. Doug, thank you for watching. Tom Usiak's on, and Gary Gerald says, good afternoon. It's good to see everyone. Gary Gerald's our favorite Vidalia onion farmer up in Georgia up there. And sorry I don't have any left, guys, but he brought me a whole bushel of them down there.
We can tell.
It's planting time. We can tell. It's planting time now. All right.
But thank y'all for joining us. We appreciate that. Really do.
Well, we love bragging about the shuttle era because I've talked with some of you people that work shuttle like you, and it's such an important part of who we are in the 21st century. Yet I'm worried that people forget about the shuttle once the International Space Station's not up there anymore. They'll never forget about the moon and Apollo, right? As long as the moon's up there. But that's why we're here, to keep the dream alive here with you guys. So let me turn my volume down here on my phone, and we can answer any questions. But there's the launch. You guys put together some patches here. I'm going to talk about the IML patch there in a minute.
Yeah.
But what patches do you choose here, guys?
Well, kind of just a number of the different patches, the mission patches, and then the crew patch, and then some of the experiment patches.
Well, I think people find it interesting that each kind of, even payloads had their own patches on there. So you've got the crew patch, the International Microgravity Lab patch. Explain those to us, the other three there were.
Well, they're definitely there. Well, as you can see on the bottom
Who
left.
would be handed those out? I mean, just the regular.
That'd be
workers on-
the payload organizations, the payload
Okay.
people would. That's something that they would have. It's kind of like, again, they're part of that mission, So they would make
So
patches and
The one in the upper left there, the IML, so the two stripes going through it are for the two, and that's the crew patch. So the one on the upper right is the payload patch. So that's for the Space Lab IML2, and then the ones you have on the bottom there are examples of the payloads. OARE, Orbital Acceleration Research Experiment, is a microgravity measurement system that was in the orbiter, and then IML2, Critical Point Facility, was one of the experiment facilities we had in the Space Lab. So all the payloads had their own patches as well.
Sweet. And there's a couple more. We love our patches. I haven't seen these either. We see so many patches in our intake of stuff here, but that IML2 is an interesting one there in the left-hand corner. Some of them are funny too, aren't they? You've got a lizard on the
there was a newt, I think.
Newt.
A newt, yeah. There was newts on this mission. So Tempest is a electromagnetic containerless processing facility. It's a German acronym, so that was a German payload. And then I think the life sciences was mostly our friends from the Japanese Space Agency.
And they did have the first Japanese astronaut fly into space. Here, I'm going to go forward here. There's their crew patch. Very simple crew patch there. Not much to read into it there. The two vectors and very, very crew 7 there. Left to right, you got in the middle there, Commander Bob Cabana, third of fourth flights, his first command. Of course, he was the Kennedy Space Center director for 12 years. And thank you for bringing Bob to Shuttle Fest there. Of course, everybody that meets Bob knows he's a great guy. He's so humble. When I introduced him at an event one time, I said, "You don't want me to say all this, it's on this page, do you?" And he said, "Heck no. Just tell him I'm Bob and I've been to space a few times." That sounds like him, right?
Now, if you know your little trivia about him, the mobile launcher that they got for Artemis.
Yes.
He had the record of running up the steps because for a while the elevators didn't work. Well, they had a contest. He had the fastest time at his age running up that tower. There was one guy that ended up beating him, some construction young kid. So it was a trivia thing. Yeah, for the longest time he had the record on. Yep, going up to the top of the ML, the new ML. Yeah.
Marty Winkel, you ever run up on top of that? I know.
Just the VAB and the.
Turn on your UCAC family microphone there.
Just the VAB and the MSS and Apollo days.
Yeah, well, he's still fit. Saw him over the scholarship Hall of Fame induction at the end of May there. James Halsell above him is the pilot, his first of 5 flights. Then you got payload commander Richard Heeb is seated on the left there beside Bob. His third of 3 flights. He was one of the 3 astronauts on the famous person EVA of STS-49, capturing that Intel satellite. Then you got Carl Waltz is standing up on the upper right-hand corner next to the Japanese flag. This is his second of 5 flights. He's a Buckeye from Ohio, as is Don Thomas, who's seated right above me here. Don is on the left side of Cabana. Don's this was his rookie flight, first of 4. And then you got payload specialist Chakai Mukai, the lady there, Japan's first woman astronaut. And boy, she is a celebrity, isn't she?
Oh, yes.
Back home. And she had 2 missions. And did I mention everybody there? Yeah, Leroy Chow, one of 3 for Leroy Chow there. So, and Leroy Chow is an American from Asian American family there. So, this was the second flight of the International Microgravity Experiment. And just tell us a little bit about what microgravity is, Tracy.
Well,
Let me go back.
the mission there, so you mentioned it's the second flight of International Microgravity Laboratory. It was IML-2 as the series, but the payload complement was entirely different. The only thing that was consistent, some of the payloads were consistent, but the thing that was most consistent, it was an international community. And it was a lot of fun to work with that kind of community. So we had Japanese Space Agency, we had Germans, Italians, British, and it was so much fun to work on that mission because we got all these cultures and their various sense of humor, and we got to work with them, on a day-to-day basis for all this time, and develop, lifelong friends. So that piece was actually a very nice forerunner for what we had later on the International Space Station. So it's kind of that whole International Space Station experience compressed into basically a year for folks like me and Mikey at KSC, where we spent most of our time building it up and then flying it in about a year's time.
Yeah, that's our point about the shuttle, Tracy, is this is the middle third of the 135 flights of the shuttle. And definitely that was the training ground for the science going on now for 22 years on the International Space Station. And the first third is before Challenger, the meat of the program where you're doing this science in the payload bay. And then the last third of the shuttle is building the space station that is carrying on these same experiments, right, in a different level. Mm-hmm. Maybe not as many animals scurrying around up there as you got on this mission, but
that's true. Yeah, and we got to learn a lot about various cultures. And for someone like me who wasn't exposed to that many international cultures when I was younger, it was quite a learning experience to get to do this in Space Lab. And you got to learn how to work with Japanese folks and how to work with Europeans and what the different temperaments were like and how to succeed in kind of negotiating and working with them, to find problem solutions in what could be stressful environments sometimes.
Did you learn a foreign language?
No, but I learned pieces of enough to know when I should get in the conversation and when I should go away.
Okay. You pick up words. Mikey, you comment about the international flavor of these missions.
Yeah, actually, to follow up what Tracy says, it's interesting because there's different ways of doing things. And it's interesting because when you try to bring all it together in one spot, which is where we worked, it was interesting because then they're trying to cram all these different cultures and processes into one system. And just one thing is like just an example is like for the Japanese are very, very efficient. We learned right away. Probably people have heard this probably before on the program, but we'd ask them a question and they'd say yes. Oh, that was easy. Then we ask them another question. Oh, yes. Oh, well, they're going to agree to a lot of these things we're asking them, right? No, yes doesn't mean yes. Yes means we understand the question, not yes to the question.
Oh.
And we learn real quick that, so they're just saying they got to go off and observe and look at that, and then they'll come back with us with an answer. So that was one thing we learned real quick.
That's interesting.
And that was just one of the aspects of working with the internationals because everybody has their own way of doing things, the different language barriers and that, but we worked around it, and like I say, it was awesome. And like Tracy says, we got to work with some of the best scientists and engineers of their space program because they had the top people that were flying the stuff on the shuttle, and we got to interact and work with them. It was just an amazing time. Yeah.
Well, guys, I don't want to date us too much, but your mission you're going to talk about is 30 years ago. And Tracy, you mentioned you're still friends with some of these people.
Yeah, folks around the world. I've traveled Europe, a few years after these missions and visited some of the folks and see him from time to time. I saw Dr. Mikey at a conference a couple years ago and said hello to her there. So yeah, it's a great way to,
How did
it's a
she
great,
react to you?
uh,
Just
just like we had seen each other a few weeks before that.
uh,
She was great. She was one of the nicest people you could meet.
huh. I find that about when and for example, if I'm the astronaut wrangler for an event, it's fun to watch them hit the door of the hotel and start looking around. Where's that guy, gray-haired guy with the bald spot? He's the guy that's supposed to tell me we're there. There he is. You know what I'm talking about.
Yeah,
You,
yeah.
particularly you and her meeting somewhere else. I bet that was special.
Oh yeah,
In
always.
your affair in there. So, well, Mikey, you're going to kick off the program. We're going to turn it over to Tracy here. So take it away, guys.
Yeah, to go back to that first image we had, yeah, that one there. That's basically, and it's just one of the racks as we're getting ready to integrate it, and then some of the crew that were there. And again, Tracy, take it from here because he was the one that was mainly involved in this mission,
As we've
pre-flight
talked,
as well as during the mission. Yeah.
if you've missed any of Mikey's shows before, we've done a lot of detail about these are very standardized racks that go into the space lab and the space hab. All right, in there. But this is the space hab, right?
Space lab.
Space
lab,
Yeah,
which is
yeah.
the smaller
The
of the two
larger,
structures.
it's the larger one.
Oh, this is the larger one.
Yeah.
Okay, I get it back.
So that's a Space Lab double rack. And what we did is we built up these racks in kind of an offline area, and we would build them up mechanically and then install the cables and come behind and do cable checks and get that rack ready. And then it went out to the floor and you installed it on that flight floor. And then we'd have build up a whole complement of the racks. And that was kind of the level 4, what we called level 4. And then once we had completed all our requirements for testing and validating all the interfaces and get everything installed, then we take that rack train down and install it into the Space Lab module, and that was what we call level 3-2.
Which is that next photo.
All
The
right.
next photo shows the module on the crane. Yeah.
That looks something familiar to us there. There's the module.
And inside that is all the racks that Tracy was talking about. What you see there, that opening, that's the tunnel. That's the entrance into the Space Lab, where a tunnel that goes between a crew compartment and Space Lab would eventually be mated together.
And you had to put all those racks through that opening there?
The opening on the other end, actually. So there was an
Okay.
end cone that was removable.
All
That
right.
end cone would come off, the whole rack train would go in.
I
Then you put
thought-
that end cone on, do your integration testing at level 3-2, and then once we were ready, it got loaded up on that handling fixture and transported out for installation into the orbiter.
So we don't have a picture of the other side, but this is a pressurized module where human beings are going to be inside. So that's like sealing a hatch when you say the end cone. That's
yeah.
that was probably a lot of detail,
A lot of works and leak checks.
leak
Yep,
checks
yep.
and stuff like that on it. So, but it always worked, didn't it?
It did.
But once that happened, the only way we could get in and out is through that opening there,
Okay.
which got real interesting, especially when you got over the OPF and the tunnels, and then now you got to go through the tunnel and to get in there, which I think is
Yeah, I'm a little
There you go.
claustrophobic on that tunnel there. You had to crawl through that to get. This is in orbit.
No, this is
No,
actually in the
it's,
orbiter.
It's an orbiter processing
Yeah.
facility. So when the Space Lab first went in, the tunnel wasn't there, and you'd have to go in on kind of a diving board that was across the payload bay, and then step down in there. But then eventually, when they installed the tunnel, then you'd have to go in through the orbiter, through the flight, through the mid deck, and back through the airlock and into the tunnel, and then crawl your way back into the Space Lab.
Now, we talk all the time, Tracy, the stuff that goes to space is made to work in space and not necessarily on Earth. So, but that tunnel, if you're crawling through it, was designed for one gravity and not.
No, you've hit on a good point there. So we had a ground access kit. So it was kind of platforms that you would install for ground access so that you could crawl through there and get back into the Space Lab. And then we were done, and when we closed out, we pulled all that stuff out
Okay.
to get it out, because otherwise it would
So,
float loose and add extra mass.
so what was it? 2x8s put together, sort of thing.
It was fancier than that, but it
Okay,
was
but yeah, but-
just basically,
Yeah.
platforms.
Okay. Yeah, because we're always emphasizing stuff in space, like we talk about the lunar module that Marty worked on with Grumman. He could not walk up and down that ladder on Earth; he would break it. it was made for 1/6 gravity
Yep,
only. So
yep.
they had
Same thing here. We could probably step right through that tunnel if we wanted to.
Yeah.
Okay, all right. We'll be thinking. So that's a big safety concern all the time: is don't touch, don't step here and there.
Well, and of course, it limits you because it's so small. It limits you on what you can take in and out of there.
Uh huh.
Yeah.
All right.
So this is one of our experiment racks. I think this is all of the Japanese hardware. So the openings up there in the upper right, I think that's where the goldfish went eventually, but it was open here. And then I think the other one on the bottom left was free flow electrophoresis unit. And I'm no scientist, and that was 30 years ago, so I don't remember exactly what the science was there, but this was all part of the Japanese contribution to IML2.
Let's talk about the written word here on my homework. The International Microgravity Lab 2 biorack housed 19 experiments featuring chemicals in biological samples such as bacteria, mammalian and human cells, isolated tissues and eggs, sea urchin larvae, fruit flies, and plant seedlings. Over the course of the mission, they studied their life cycles, effects of microgravity, and cosmic radiation on living tissues. So,
Yeah, we don't.
jellyfish, plants, and even some goldfish we're going to see a picture of.
Yeah, one thing you mentioned was the glove box. Well, I don't think I have a picture of the glove box in here, but a glove box is basically a small experiment facilities that the astronauts could reach in with gloves and do things that might be hazardous or have some biological things that you may not want to mix with the astronauts. So we had a German glove box called Biorack Glove Box that had actually flown once before on Spacelab D1, and it actually flew later on Spacelab D2.
Yeah.
I
I think we got a picture of it on orbit with the crew
Okay.
working on it, but not when we didn't get a picture of it
Okay,
pre-flight.
let's put this next slide up here.
Oh, that's Tempest. So Tempest was the German payload electromagnetic containerless processing facility, and Tempest is a German acronym.
Okay.
But it was basically a manufacturing experiment where they melted metal and then reformed it and then brought the samples back to Earth to study how they crystallized in space. So you could see how the metal would naturally form without the influence of gravity. So it was a high temperature furnace that consumed a lot of power.
And required a lot of safety, I imagine, too,
Oh, yes.
on board there. Fire, fire, fire!
So these were two of the Spacelab video tape recorders, and they were notable because there was 4 videotape recorders, and this was back in the day of analog video.
Tape recorder,
Tape
like
recorders.
like
Like VCRs.
Okay.
Yeah.
All right.
So these were the old school videotape recorders.
but the highest tech available, I'm sure.
At the time, they were fairly modern when they first came into Spacelab, but this was later in the program, so they were getting older by then. And they didn't record for very long, so maybe it was a couple hours, and the crew would have to go in and change the tapes so you could keep recording. And they had an archive of what experiment video was on which tape. But there were 4 videotape recorders, and 2 of them went down during the mission and couldn't record. So then we were in a bind for, well, how do we record the science that we need to capture? And I supported this mission from the Haas, because I think Mikey mentioned, which is in Huntsville. So when the missions launched, the Spacelab mission launched, JSC Mission Control controlled the space shuttle, but Huntsville, the Huntsville Operations Support Center, controlled the payload. So when we would launch, sometimes I would fly to Huntsville and support the mission there. And this was my second or third time doing that. And then by that time, they said, well, we just want you to work problems. Because I think the first time I was there, I worked a regular console position. So I floated and worked problems. So they asked me to help with this problem. And we had to figure, well, what if 2 of the VTRs are down and we can't record all the video we want, what will we do? So we came up with a couple of workarounds. And one of them was relying on camcorders and just filming. You could put the video on the monitors in the Spacelab and just film it with a portable camcorder so that you had it recorded one way. Alternatively, you could send the video to a monitor in the flight deck, and you could plug in a camcorder to that. And the reason I'd never used those before, but at the Haas, Kathy Thornton, who was a astronaut crew member who flew on a different mission that I had met her on. She said, "Hey, you guys might want to use that." And I didn't know about that, so I offered that suggestion, and that's something we ended up doing. Out in the video up there, you could plug in a camcorder directly to the monitor, and that way you could record the pure analog signal, which had some time encoding that our experimenters wanted that we weren't getting if we just put a camcorder on recording a video screen. So we had to work through these sorts of things.
Boy, today just stick a thumb drive in there. We saw Kathy this week. Today's her last day at the Kennedy Space Center Visitors Complex as the astronaut of the day. Really have. Marty, you got a question?
Well, Robert Lowe has a question. He's asking, were they VHS or VTRS?
They were VTR. As far as I knew, they were a unique tape system that was for Space Lab. I don't think anybody else had that kind of tape.
Yeah, it wasn't like the VCR tape you'd have at your house. It was
Good question,
similar,
Robert. He's
similar,
up in Robert's up in Dundee, Scotland. It's 9:30 at night there, so he's enjoying his cocktail on a Thursday evening. William Whiting, hello up to you in Michigan, and a new name, Chris Giorgio. Thank you for the engineering details, says Chris Giorgio, and thank you for watching today. And tell your friends this is the only place on YouTube where you're going to talk to real space workers of the shuttle era, the Apollo era, even this era, and we call them all national treasures because things that you did 30 years ago pioneered what we're doing at the International Space Station now. So,
and one other pre-flight thing I want to talk about was a test that you want to explain kind of what you were able to.
So one of the things that we did for each of these missions is we did a mission sequence test, and traditionally, so mission sequence test would be normally at the end of the campaign in level 4. And it was a week-long test. Usually it was a Monday, Wednesday, Friday. And in those tests, we'd pick off a slice of the mission, like a 4-hour slice. And it would take us a few hours to get ready and into configuration. Then we'd run the slice with the astronaut crew and the mission operators. And then we'd have to break it down. We'd take a day off to reconfigure and do the next one. It was a lot of work, but they were really successful and helped the crew train. It helped us work out problems. And the kind of things you would study in those tests would be like maximum power draw, maximum data flow. Maybe when 2 crew members were working in one area, you'd look for any sort of EMI or other interferences. So it was a test designed to test the extremes of the mission operation parameters. So we did those tests in level 4, but we also usually did them at the end of level 3 too. This usually was the same test. And in this test, in this flow, we proposed actually just canceling the second mission sequence test based on experience. And I think Joni Richards is actually the one who came up with that. Mm-hmm. And I think at first I was against it because I like the test and I want to make sure everything works. But when we had a team go off and look at the previous tests, mission sequence tests we had done in other flows, we weren't really uncovering new system compatibility problems the second time you did it. You might uncover some other nuances, some other minor problems, but it wasn't the big system compatibility problems. So when we proposed deleting the test, we ended up negotiating to kind of a middle ground, and we ended up scaling it back to a 1-day, we called it like an interface compatibility test. So it was really a 1-day test that was really designed at making sure there were no new system problems that came from being introduced into the rest of Space Lab. So it was, based on the lessons learned from our previous experiences, trying to make things more efficient. And that's what we've always tried to do. And even though it was a big change, it was, by the end, it was, it eventually got to, hey, this is a good idea. It's going to save us some time and money, and it's a lot less work to do it this way.
Saving money is, of course, a big deal. That sounds like a Snoopy Award worthy of thing. A Snoopy Award given, Silver Snoopy given to outstanding employees, particularly those that save things. Did that happen with you?
It did happen with me, not on this particular test, but I think I got one on when I worked on Neurolab.
Okay.
So got one a little bit later.
STS 90.
Yeah, and that's one of the other videos.
K higher.
Yeah.
Yeah, remember that. Yeah. And then K waited 12 years to go to STS 130 with the cupola on there. So Well, great. We're talking with Tracy Gill here and Mikey Haddad. They worked in what was called Level 4, an area of the work area at the Space Shuttle uh, facility where you put it all together. SPF's Space Shuttle.
Well, this is actually in the operations and
This is
checkout
in the
building.
ONC,
Yeah,
Operations
Which
and
is
Checkout.
the Neil Armstrong
called Neil.
operations and checkout building.
All right. But anyway, we enjoy hearing these real stories of putting real science in space 30 years ago, pioneering what we're doing today. Got another bunch more images here. There's our.
That's just a kind of a side view looking down the floor. So the the center aisle is kind of there on the left where you see some hardware stowed, and that's kind of one side of racks along one side, and then there's another side of racks on the other side of the center aisle there. It just thought it'd be good to see that kind of overview. And then at the top there in the middle, you can kind of get a little image of the glove box we mentioned earlier. That's kind of a piece of the glove box up there with the.
All right.
And the little white things on the floor were footholds. That's what the crew used to slide their feet in to be able to hold them. in front of the
Loops to
racks.
put their
Loops.
feet in
Yeah.
to stabilize them
Yep.
there. Okay. Super. Marty, you've got a great question from one of our wonderful followers, Dean Babcock. Take it away on that UCX family microphone, Marty.
Okay, Dean's asking, how were the experiments selected to be taken to space on this flight?
Oh, well, they had a long process of a manifesting process that they worked. So these Space Lab missions were managed by Marshall Space Flight Center. And they had a program management team and they had a science team. And people would propose to fly experiments. And there was a down selection process and a chief scientist. And it was a fairly long.
Yes.
That process probably started maybe 5 years before
Yeah.
a mission.
Exactly.
A number of years before the
Number of
mission ever
years.
flies.
Because they had to propose the concept and then they had to build the hardware and then get all the hardware qualified so that it could be delivered to us. So it was probably about probably started 5 years before launch. It was probably a couple year process
Hmm.
to get them selected and ensure that they were going to be built. And maybe if one payload wasn't going to make it in time, they'd have to sub in another payload that might be for a future mission or maybe something that had already flown in the past.
Yeah, it was a rigorous process because there was a number one put in for the mission, but of course only those numbers were selected and flown. So it was an interesting process to do that and get them all.
Great question, Dean. Who was the body that decided you're going to make the cut?
Well, there was a program management team, but I think they took their call on what payloads were, what the science was recommended by a science team. So I think it's a mix of, the science that they were doing as well as, the maturity of the concept and whether they thought it could be ready in time for the mission.
Mm-hmm. All right. There we are in outer space.
Now we're in space. It's a beautiful picture.
This was a long mission, 15 days. Obviously maximizing a lot of science up there.
Yeah, and I think they got an extra day at the end where they had to wave off landing and the space lab was already closed up, sealed up for landing, and the crew got to spend a more of a relaxing day
Looking out the
on
window.
their extra day, yeah.
Yeah.
Which was probably
Well, ask
great.
Don Thomas about that. He's going to be in our building in November.
Good.
Talking to the Japan-Florida group that we love having.
That's a
here.
nice segue because I think this next picture, that's actually a picture Don Thomas took. He says the first orbit, they flew right over Kennedy Space Center, and this is the picture he took from looking out the window. So that's a Don Thomas one there. Yeah.
Looks like the clouds in the morning, ready to become angry storm clouds in the afternoon here at our Florida cycle there. But there you see Rocket Row right beside me there. The vehicle assembly building's probably right in there. That's a gorgeous shot there. We love that. Marty, we may have to make that one of our green screens, put that in our collection there.
So this is a cue for one of my favorite stories,
It's an awesome story.
Mikey has this in the book. But like I said, I've supported these missions from the Husk, and when this mission launched, I got on a plane and I flew on my way to Huntsville to support the mission. So I think I connected in Atlanta, and by that time they had got to orbit and they had activated the space lab and started getting data flowing. And I called in to one of my colleagues to say, how's the mission going? So everything's going great, except our Japanese folks are not getting their data. they're seeing, some something that looks like a signal, but it's not quite, the data is not readable. So I said, well, I remember, we fixed a cable for them on the ground, and that picture there shows we had these high rate multiplexer cables, and it was kind of a tricky cable, and our experiment cables are on the right side of that bracket. And that was connector bracket 50, CB50. So our payload cables were on the right there, and the payload cables were this special Gore cable that was for high data rates. But at the end of that, they had to have a solder sleeve to go into kind of a more common copper wire, so that went into the connector. And they were a very tricky cable to build. And they had a solder sleeve on them that had to be melted in place to secure the one side of the wire to the other side of the wire before we went into. And we commonly had problems with them. And the way that we would troubleshoot them on the ground, as laughable that this is, my wife always laughs at this. We would grab the cable and move it around a little bit to see if it either introduced a problem or fixed the problem. And if you had a change, you knew that you probably had a bad solder sleeve and you needed to fix it. We specifically fixed this one cable interface for the Japanese on the ground. And I said, in Atlanta airport, I said, oh man, just tell the astronauts to wiggle the cable, and that might fix it. That might be it. Or at least know that, whether that was the problem. Well, I continued to fly and got to Huntsville, and I came in and said, well, did you guys get to do that yet? And they said, well, we caucused, and the decision was, well, we don't want to go up to the crew with anything but a complete troubleshooting plan of all of our options. So I said, okay, well, the only other thing you can do is, if this is what the problem is you could build a bypass cable from here to there. And I said, okay, do that. And I said, okay, well, so I worked with an IFM in-flight maintenance toolkit expert on building a bypass cable and a couple other things we could try. And it took us about 41 hours before that was ready and prepared. And I have a copy of the
Awesome.
the procedure that was faxed up to the crew to say, hey, here's what we're going to do, our troubleshooting plan. And I think it's 3 pages, and it shows the wiring diagram and all that.
Approved for uplink.
Approved for uplink. So I go in, I mentioned I was a troubleshooter during this mission. So I go in the middle of the night or whenever it was to support this troubleshooting plan. And I walk in the door and I hear, hey, our data's good. We're happy. Everything's good. And I'm like, what happened? And so we found out that actually right after that, the astronauts call up and said, hey, we've got this procedure. We're ready to go. I've opened up the floor panel. I grabbed the cable to make sure I knew which one we were working on, and we're ready to start. But when he grabbed the cable to figure out which one cable we wanted him to work on, the data locked up. So it was a loose connector, and we said, you're in microgravity, it's fixed, don't touch it, close it up and walk away. And so the data was fine for the rest of the mission.
And so initially his suggestion would have worked 40 hours
Yeah.
earlier if they would have done it.
Right.
Yeah.
So they lost 40 hours of data because
Well,
they didn't go over and wiggle it.
they decided that they could get by without that particular data feed for the first experiments they were doing. I still wish they had done it,
Yeah.
But I mean, I understand we when they wanted to have a plan for all their options. But I think we've matured over time, especially when we got into space station. We're less conservative about, trying things. And that was the level 4 spirit. Hey, just go try this, make it work. At that point in the shuttle program, we weren't ready to do that kind of aggressive troubleshooting that maybe we're probably a little bit more comfortable with doing that kind of thing on space station now.
Looking at this fax from Tracy here, I actually see that page 1 of 3, 45 lines this page, and each line is numbered on the side here down to 45. I find that, and it's approved, and then you got the kind of a hand-drawn page here.
Yeah, it's a wiring diagram.
The wiring diagram. Is that your handwriting?
No, that's not my handwriting.
Yeah, on there. So, but 41 hours later, they just wiggled the line and it worked. And
Yeah,
it worked.
yeah.
So-
And this is a fax, and people don't even know what a fax is anymore.
No, they don't know what a fax is. The last time you sent a fax, you didn't know it was going to be the last time on there. But Well, all right. We're enjoying Tracy Gill here with Mikey Haddad, talking about STS-65 30 years ago, International Microgravity Lab experiment with 7 astronauts. I imagine it was a pretty successful mission.
Oh yeah, for sure. Yeah.
All right,
In
let's
fact,
see what
there's-
other picture you got racked up there.
There's Don and Leroy working in flight. I sure hope it's in flight because
Yeah. That's
Yeah.
yeah. Like,
So
Yeah,
Leroy's
yeah.
floating,
yeah, Leroy's
jumping there.
floating above
Don
him.
Thomas on the bottom, Leroy Chow there. So you did interact a lot with the astronauts before the launch. Was there a certain cycle that they would come, like a month before, and then come back a week before, or what was that like?
Primarily it was with those mission sequence tests. So that, the level 4 mission sequence test, they were there at KSC supporting the test. It was like a dry run for them. And with this crew, it was with Rick and Leroy and Chiaki.
Rick Heeb, and there's
and,
Cabana.
That's the picture's not in front of me. Oh, by the way, I brought my picture. This is my signed crew picture. So Dr. Mukai
Yeah.
and Don Thomas. So it was 4 crew that were really so that's one of the nice things they usually did for us, for the workers on a mission like this, is we got a signed crew photo, and that's mine. So we primarily interfaced with Chiaki and Don and Rick and Leroy because they were the payload crew. So most of the activities fell to them. The other crew members, especially when we did a mission sequence test, they would do the not as invasive activities. They would come through and change the video tape recorder tapes, or clean a filter, or we had a SAMS, a space acceleration measurement system, that had optical drives. They changed the optical drives. So they kind of did the ancillary tasks and let the 4 primary payload members do the real experiment activities, because those payload crew members had been the ones mostly working with the scientists and the payload developers and really understood the experiments well. The other 3 were more shuttle crew members that kind of took care of the orbiter for the most part during the flight.
Now, of course, you're on the ground. There's an up and a down, but there's no up and down in space. How'd you figure out what you were going to put up on the ceiling, so to speak?
Well, in space, it didn't really matter at all,
Right.
but on the ground, we really didn't load those until we were ready to close everything out. So we didn't, when we needed the pieces of the experiments, we just went to some lab and got them out, used them for our testing, and then put them back until we were ready to load them for flight right at the end. Because if you had it installed above you in 1G, it was effectively inaccessible, because you'd need to,
Yeah.
you couldn't reach those very well, and it had a lot of mass in it, and if you released it, it would fall down on you. So you didn't want to load those until you were
Okay.
ready.
So for the astronauts, going in space is the first time would have that configuration. Because you hear of astronauts, Story Musgrave, for example, drew a famous story about him is when he was going to space and doing spacewalks, he knew that he would be disoriented because there's no up or down.
Right.
So his children would say they'd come home and the TV would be upside down and a couch would be on its side, because he was going to sit in there and kind of get his brain used to seeing things in a
Okay.
different way. It
Wow.
was all to
Okay.
adapt your brain.
Hmm.
He would, and I've heard of astronauts putting a chair in the middle of the floor and sitting on it with their back on the ground, like they would, because they're for the flight, because you might be 5 hours sitting there on your back in the shuttle cabin before the flight, so they wanted to make sure their body was.
Well, Space Lab was more oriented with an up down, with the racks like that, and we called that the overhead, and then you had a floor. We evolved on Space Station where they took better use of the volume, and you kind of had 2 racks faces like this and 2 racks kind of faced like that, and so it was less of an up and a down to make better kind of use of the volume. But Space Lab was kind of nice in that there was a perceived up and down, even if you were in microgravity.
Very good. Well, here's another good question from Dean Babcock. Marty, take it away.
How soon after landing did you remove the experiments, and were they done at? Can we do it?
Where was this done at?
So there's two answers to that. So some of the equipment would be on the mid deck, and I think the Goldfish and and some of the other samples and things were stored in freezers and other facilities in the middeck so that you could go in on the runway and retrieve it.
There's goldfish.
So there's the goldfish. So the other piece of that, things that were not as time critical, that didn't need to be powered, you could go back into you would actually take the orbiter back into the OPF, back in the 39A area, and we could retrieve it in there. So it was kind of done in piece parts. Things that were time critical, you could retrieve those on the runway. We even had an access kit that you could go back into the space lab and get them if you needed to. And then if it was less time critical, we would wait for it to come back into the OPF and go in and get the samples. And we'd get some of that samples in the OPF. And then it was probably a month or so after flight that we'd deintegrate the space lab and bring it back to the ONC building where everything could be broken down in detail.
Thanks for your question, Dean. The Orbital Processing Facility, the OPF, the 3 garages around the vehicle assembly building, and we have every month Terry White, one of the chiefs of the OPFs, comes and does a program with us, just like you guys. We'll have to get you, Terry, and Nick Thomas does a monthly show.
Okay.
We ought to do a show with all 3 of them together, Marty, one day there. So
One other thing I wanted to mention was the Tempest. You talked about the commands that were sent, about the number of commands. Had over 26,000 commands sent.
Yeah, I mean, that was unheard of.
26,000 commands.
for one payload.
One payload.
So
Wow.
that was unheard of in that time. I mean, now it's normal, but I mean, it used to be that you'd have a few commands and your telemetry wasn't that much. As a matter of fact, these were some of the first experiments that actually started digitizing video images and putting them in packets and sending them down through telemetry. And, this mission I mentioned we had analog video. The mission after this, STS-73 USML-2, we had the first digital television system that flew in space as a payload, where we were able to get more, video down per mission.
Downlink video
Downlink.
live on there.
But, this was really kind of some of the pathfinding payloads that increased our uplink and downlink usage.
Okay.
Amazing.
The TDRS satellite come into play with this, the tracking data relay stations.
All of our data went up and down through TDRS.
Uh-huh. Okay, and the TDRS satellite launched, I think there were 7 of them that they put in orbit up there.
Still we're using them now. We're starting to trend away towards TDRS and start to use commercial assets, but we're still relying very much on TDRS today.
Yeah.
Well, we're coming into an end of another wonderful program behind the scenes of these payload specialists orbiting things around the Earth that eventually these ideas are doing right now on the International Space Station. Hope that manned space enjoyed that. That's Mitch Rothman and Robert Law. It's great to hear from you, and Dean Babcock. Got some new people here, Marty. Eric Pert, thank you for watching, Eric. We've also got Chris Giorgio and Tom Colbert watching today's show. Any of your families or friends out there watching today? Tommy Usiak, Gary Gerald, Doug Forrest, Steve Jokums, Dave Stange, and Dean Babcock, thank you for your great questions today. Got a couple other slides here you loaded up.
Yeah, just real quick.
Yeah, go
this
Browns.
This was I became good friends with Don Thomas, Carl Walls, and Leroy. And this is during one of the times when I was doing the Atlantis exhibit. Don used to come down for the astronaut encounters at the visitor center.
Yes.
And he kind of surprised me. He just kind of walks in, "Hey, Mikey, how you doing?" And then, and of course he had his Cleveland Browns. That's Jim Brown from the old Cleveland Browns. He has his Browns jersey on, so I got a picture with him. And so we're still friends today. I actually met him through his wife. And his wife and I were working a project together at JSC, and I was trying to be an astronaut at the time. And she goes, "Oh, my husband's an astronaut." I go, "What?" So we met for dinner, and that's when we started talking about football and the Browns. And he actually took a Cleveland Browns thing up there and put it in the middeck. So this is just a picture of what we got. He came down from Florida for one of the events.
You grew up in Cleveland. I grew up in Ohio also, so good. He's a great guy.
Yeah, he
is one of the hardest working astronauts out there. Him and Nicole Stott and
Mhm.
a few others, just always doing outreach. And I think he does 300 dates a year.
He's always doing
Yeah,
something.
yeah.
These guys got energy.
He's
You
at a
wouldn't believe.
school every. You better believe he's at two probably schools every week
Yeah.
on there. So
Yeah.
we'll get Don on here one time on there.
And I think there's just one more photo, and we're done.
Yeah.
This is basically the site that Maynette Smith set up. It's a website, and kind of this does, and in the bottom is the web, the www, the whatever it is that you call it, for the site. And this site does two things. It's for people, anybody out there who worked the Space Lab program. This is the place for you to just go and basically dump your brain. Say what you did, how you did, interactions, all those things that happened in the Space Lab program. We wanted to get the people that we couldn't talk to or get, or see these shows that, their information's still in their head, or they've talked to people. This is a place where they can go and write it all down. Hey, this is what I did on Space Lab. These are the things we did. These are the people we meet. These are the problems we solved. So this site does that. But it also is a place where people can go to read about that. So you got people that can input to Space Lab, that they worked on Space Lab, and anybody who wants to learn about Space Lab can go to this site and learn about, get that information from those people like Tracy and I, who were in the trenches, kind of thing. So I just wanted to show this. I haven't showed it in a while, but it's a website out there just for people to go to do that, because there's so many people out there who work Space Lab. There was also these science experiments. I mean, how many PhDs and how many papers written from all this science that came, and all those people that were involved. And what did you do? Well, I worked on the lab that this experiment came from in 1985 or something. Put that information here. We want to hear about that. So that's kind of why we developed this website, is for anybody who works Space Lab. And again, it's not just experiments. It could be Space Lab module. It could be anything associated with the Space Lab program out of Marshall, out of J.S. Johnson Space Center. And then again, for people to read about that, because the book is only 500 pages. You can't put 30 years of payload ideas into one book. So this is to try to expand that information that really didn't get in the book, so people can learn more about Space Lab and the things we did and the successes of it. Yeah.
Yeah, I'll share that information on our Facebook page there to help you get some more people involved in that. There's all kinds of Facebook pages for the space workers out there, including ours, where we love posting things that other space places might ignore, where we're all about Cape Canaveral and what's happening here on the Florida coast. So thank you guys.
Let me add one more
yeah,
thing.
sure.
So one of the, I mentioned this was one of my favorite missions, and that's kind of like asking, what's your favorite child? So it's probably in my top 5 or top 3, but again, that international flavor. One of the things we did as a social on one of the sims that we ran. So before the mission, you'd have simulations that we ran from Huntsville, and on one of those times after the sim, we had a group tour where 80 of us went on a bus to the Jack Daniel's distillery in Lynchburg, Tennessee, with this international crowd. And that might be, among the top favorite things that I remember about Space Lab, because it was all these people just having a great time and socializing. And we had this catered party, and we all bonded over this experience, and we took the bus there and back, and it was just a hoot. And, that's why, these experiences develop lifelong friendships, because you got to do all these fun things together.
Jack Daniel's Distillery. I've been there. That's, but yeah, like you said, just an hour and a half or so from Huntsville.
Not too far.
In there. Chattanooga is over there also, near Huntsville. So another beautiful city.
Yeah.
I love going to Chattanooga, but very good. And Tom Colbert is watching from Ireland. Okay, so he's also having his Wednesday night kickback up there.
We're big in Ireland, right?
Yeah,
yeah.
we're big in Ireland. Right.
Yeah.
Tracy, thank you so much
You bet,
for
Mark.
sharing your stories there. Mikey, again, thank you for all that you guys bring to our
You're
museum
welcome.
here. It's important for our outreach, but it's also important for us to keep your dream alive, your memories alive, and your stories alive. As you heard stories today that you're not going to hear anywhere else except on Stay Curious. So glad that you all enjoyed it today. Thank you, gentlemen. Thank you for a good job, Marty, on the Streamlabs there with Logan Cope, our intern there, looking over your shoulder today. Marty's going to hit the road and go on vacation starting next week. And we're going to have a recorded show with Jim Blackwell, a gentleman in his 80s that worked on communications in the early days of the space program, a program we recorded a couple weeks ago. So you'll be able to enjoy that tomorrow, as well as Friday. We're just going to recap all of July, I think. Two wonderful moon missions, Apollo 11, Apollo 15. And so Friday we'll look back a little bit and maybe have some future Friday stuff going on. But a lot of you like just kind of looking around current events. A lot of good current events going on. We got to get the Butch and Sonny back from the International Space Station safely, but it looks like they had a good test on that over the other day. So until tomorrow, when we've got another national treasure, Mr. Blackwell, telling his story, I'm Mark Marquette saying we can't wait to see you in our museum to bridge the space between us. Thanks a lot, guys.